How do we apply the laws of cosines to side, 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 and side angle side? Just as a reminder, the law of cosines is c squared equals a squared plus b squared, the Pythagorean theorem, minus 2ab cosine c. All of this is multiplied together, negative 2 times a times b times cosine of c. And the important thing about this is that angle c has to be across from side c. It's not important that they're actually labeled c. It could be a squared equals b squared plus c squared minus 2bc cosine a, as long as this side is across from this angle and these are the other two sides. So how do we apply the laws of cosines to side, 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 and side angle side? So we're going to identify that it's side angle side or side, 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 and we're going to treat them differently. If it's side, 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 we're going to set up law of cosines to find the largest angle. And if it's side angle side, we're going to set it up to find the missing side. There is a big reason why I say the largest angle. I say the largest angle because cosines, law of cosines will give us something different in quadrant 1. It's positive. And in quadrant 2, it's negative. I find the largest angle so that if it's in quadrant 2, I'll know. And then I can start just using law of sines. Then we find the second angle using law of sines if we're in side, side, side. Find the largest angle using law of cosines if it's side angle side. So if it's a side angle side problem, hunker down. It's going to be a long problem because you have to use law of cosines twice usually. Then we'll find the third angle. Once we found two angles, we find the third angle using the triangle angle sum theorem, the fact that there are 180 degrees in a triangle. So let's see. This is, well, the angle, there's an angle and it's between the two sides. So it's side angle side. So side angle side tells me we should be setting up law of cosines. Now I'm going to set it up with this side as the one on the other side of the equation. So b squared is going to be equal to a squared plus plus c squared minus 2ac cosine of b. The important thing is that the angle is across from the side. So 27 degrees. Cosine of that times 2 times 17 times 28. And this is 17 squared. This is 28 squared. So 17 squared is 289. 784 minus all of this stuff. So this is, I believe, 510 cosine 20. I'm sorry, that's not true. I mean, we're going to be using a calculator anyway, so it doesn't really matter if we multiply this out. 2 times 17 times 28 times cosine of 27 degrees. When we take the square root, we get b is approximately equal to 15. So I'm taking the square root of both sides, and I'm typing it all into a calculator. You're going to be given a calculator if it's a law of cosines problem. So it's 15, and that's the side length. This is 15 feet. Now we have found the third side. We need to make sure that we know the largest angle. So we need to find the largest angle. The largest angle is across from the largest side, so that means angle C. So set up the law of cosines again. C squared equals a squared plus b squared minus 2ab cosine C. Well, c squared is 28 squared. And a squared is 15. B squared is 17. 2, 15, 17 times cosine of C. Now we get 784 equals 225. Oh, look, I was thinking ahead. 289 minus this whole thing is 510. So now we move these to the other side by subtracting 225 and 289. We're going to get all this is 270 equals negative 510 cosine C. Divide by negative 510. Get negative 9/17 equals cosine of C. And that tells me that C is going to be approximately, take the arc cosine, 122 degrees. Now, if we had used law of sines to find that, we wouldn't know whether it's 122 degrees or the supplement, whether it was that or 58 degrees. So this is going to be a much better choice to use law of cosines for our largest angle next. So we found this. We found that this is 122 degrees. And you could now use law of sines or law of cosines to find the third angle, but don't. Find the third angle using that there's 180 degrees in a triangle. So you have 180 minus 122 and minus 27. So that is 31 degrees is our last angle. So that's approximately what the angle A is. All right, so this is solving a triangle with side angle side. We found the missing side first using law of cosines. Then we found the largest angle using law of cosines again. And lastly found the third angle by using 180 degrees in a triangle. Law of cosines with side, side, side. So law of cosines with side, side, side. We should first find the largest angle. So b squared equals a squared plus c squared minus 2ac cosine b. 29 equals 13 squared plus 21 squared minus 2, 13, 21 cosine b. And now we're doing a lot of arithmetic, mostly with a calculator. 441 minus 546 cosine b. Move everything to the other side of the equation. So subtract these and you get 231 equals negative 546 cosine b. Divide to get that this is approximately negative 0.423. And then b is approximately 115 degrees. So now we have one angle. We have the largest angle. Once we have the largest angle, we can be confident that all the other angles are acute. So we can just use law of sines for the next one. It doesn't matter which one you use it on. I'm going to use it on angle A. So sine of A over A, which is 21, equals sine of B, 115, over 29. Multiply this out, we get sine of A equals 21/29 times sine of 115. Now simplify the right side with a calculator. 0.656, that all multiplies to. And then we take the arc sine of both sides, and that gives us 41 degrees approximately. That's supposed to be 41, not 4.1. So we have two of the angles. You could apply law of sines or law of cosines to find the third angle, but don't. You should use that there are 180 degrees in a triangle, subtract 115 and 41, and you should get out that 7 minus 5 is 2. 24 degrees is our third angle. So that gives us A, B, and this was our angle C. That is how we apply law of cosines to side, 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 and side.